Today's my presentation is about machine harvesting for fresh market quality blueberry. Blueberry is an important crop in Pacific Northwest, and Washington is the second largest national producer. Among them, most of the blueberry is for processed market, and only 30.8% is for fresh. Being a huge blueberry producer, growers in Washington encounters many challenges. For fresh market blueberry in our region, they are usually harvested by hand. It is very labor intensive and costly. It requires up to 600 work hours to harvest 1 acre of blueberry field by hand, and the cost can be up to $9,800. A survey in 2016 indicates that high labor costs, decreasing labor availability, and high competition with other jobs are the major constraints to the Washington growers. Furthermore, there was a recent lawsuit between Circle, a blueberry producer in Yakima, and federal government regarding to the labor wage. The mandatory increase of the labor wage could potentially wipe out growers' profit. Like what Circle said, replacing hand picker with machine can be one solution to the labor issue. Over-the-road harvester can reduce labor hours to 10 work hours per acre, and the cost can be reduced by 85%. However, harvest efficiency and food quality are jeopardized. Ground loss from the gap between the catching plate or the packout loss from removing unripened fruit both adds up to low harvest efficiency, and the yield loss can be up to 40% in southern high bush blueberry. Furthermore, berries harvested by over-the-road harvester tend to have more water loss, more bruising incidents, and less firm compared to berry harvest by hand. Two images on the bottom right are the cutting surface of Liberty 24 hours after harvest, and the incidence of severe bruise is circled in red. As you can see, there are more incidents of bruising in machine harvest blueberry. Researchers found out that bruising is positively related to dropping height and surface material, and most of the mechanical impact takes place when berry contact with the catching plate. By replacing the catching plate material from metal to net fabrics or foam sheets in semi-mechanical harvesting system, Dr. Fumi Takeda found out that there were less impact and bruising in southern high bush blueberry. 2018 trial conducted by Dr. DeVater and Dr. Young found out that slightly less packout, less firm in Duke harvest by modified harvester with soft catching plate compared to hand harvest, but the result is still better than conventional harvester. Therefore, modified harvester with soft catching plate can improve machine harvest blueberry quality, and it has the potential to harvest fresh market blueberry. The common strategy for machine harvesting blueberry is usually start at higher percent blue, and the harvest interval tend to be longer compared to hand harvest in order to decrease the labor cost, decrease the yield loss, and increase harvest efficiency. However, the prolonged harvest interval may also increase the potential risk of insect disease or environmental stress. And furthermore, the fruit quality keeps changing during the prolonged harvest interval. From the pictures on the bottom, you can see that during the berry ripening, sugar content keeps increasing and acidity keeps dropping. Therefore, it is important to study the harvest efficiency and food quality during the different harvest interval. This leads to my objective. First, evaluate harvest efficiency and the resultant fruit quality in southern high bush blueberry using a modified old-row harvester prototype compared to hand harvest and traditional old-row harvest. Second, determine optimum blueberry harvest interval for important cultivars to maximize fruit quality and harvest efficiency. Let's move on to the method part for my first experiment. First, I want to introduce you the modified old-row harvest prototype. The harvest I use is Oxbow 7440 with orbirotor picking head. And from the picture in the middle, you can see soft material was installed on the catching plate. And from the right picture pointed by the red arrow, additional soft material was inserted above the conveyor belt designed to further decrease the impact. And this setting was only used in my Draper experiment. This is my plot maps for Duke and Draper field. There was 3 harvest treatment, hand harvest in blue, conventional over-the-row harvest in red, and modified over-the-row harvester with soft catching plate in green. Each harvest treatment replicates 3 times, and each plot is 60 feet long. The Duke was harvested at 95% blue on July the 19th, and it was packed on the same day. The conventional harvest I use is Cont 7420, and Draper was harvested at 85 to 90% blue on July the 31st, and it was packed on the second day. The conventional harvest I use is Oxbow 7420. The harvest efficiency assessment data I collected is in-row ground loss and percent packout. For in-row ground loss, I put a 1 meter square quadrant in the center of 2 random plants 4 times per plot. And then I collect, numerate, and weigh the berries inside the quadrant. For the percent packout, I use packout weight divided by the initial weight. I also collected percent sawdust, which is percent color and percent soft. After packout, berry was stored at 4 degrees Celsius and 95% humidity for 28 days. Food quality measurement takes place on 1, 7, 14, 21, and 28 days after packing. The food quality measurement includes firmness, water loss, and incidence of bruising. Firmness was measured by FirmTech 2, and the water loss is the average weight difference between day 0 and evaluation day divided by the weight on day 0. In addition to visual estimate the bruise area, a digital imaging system is used to quantify the incidence of bruising or tissue injury. The berry was first cut in half and put inside a phenotyping box, and there was 2 white fluorescent light tubes inside the box to give a uniform illumination. And there was a small hole on the top of the box which can barely fit the camera lens. I took picture from that hole. And the image here is the picture I get from this setting. The image analysis was processed by Dr. Sankaran and her graduate student. So after getting the image, it undergoes the radiometric calibration first. In this step, the digital value of each pixel of the image was standardized. And then the image threshold was adjusted to a point that the blueberry is separate from the background. And since the healthy tissue is lighter than the damaged tissue, when you further adjust the image threshold, eventually the healthy tissue will fuse together with the background, leaving the potential bruising area. But this potential bruising area also includes the fruit skin and calyx. So In a HSV image, the full skin and calyx were removed, leading to the final image. And the last step was quality check. And this is the ground truth result between the bruising area analysis by the algorithm and visual estimation. As you can see, they have a positive correlation, and the R value is 0.68. However, the algorithm tend to slightly underestimate of the bruising area. So we are still working on improvement the algorithm to give a more accurate reading. And those data is not ready to present today. Next is the method part for my second experiment, Harves interval experiment. And this is the format for the Liberty field. It was a 2x3 design. There was 2 harvest type, hand and modified harvest with soft catching plate. There were 3 harvest interval, 3, 10, and 14 days. On the first day of harvest, each 9 machine harvest row plus hand plot A was harvested. Then the 9 machine row was randomly assigned the harvest interval and get a second harvest, which is 3-day interval, 10 and 14 days interval. One thing I want to point out that is the hand plots was not follow the harvest interval design. The reason for that is we don't have the enough labor to harvest the whole hand plots on the first day. The harvest efficiency data we collected is % blue before and after machine harvest. On the first harvest, I randomly tagged 20 clusters in one plot, and then I compare the remaining blue food before and after the harvest. And for the second harvest, I visually estimate the % blue before and after. The Packout data measurement is same as experiment 1. Food quality measurement is also similar to experiment 1, except I didn't measure the water loss data. And in addition, I will measure soluble solids, pH, and titrable acidity data. However, those data are still under processing, and I will not present them today. Let's move to the result part for my first experiment. This is the in-row ground loss data for Duke and Draper. Duke's data is on the left and Draper's data is on the right. And Draper's data is present in weight. The reason for that is I didn't get the total yield to calculate the % ground loss. And the only statistic difference was in hand harvest Duke, which is the highest 1.4%. And there was no statistic difference between the conventional overload harvester and the modified overload harvest in ground loss. The reason for the high ground loss in hand-picked Duke is due to the late picking. Since the Duke field is designed for machine pick, so it is, we start picking at 95% blue. It is too blue for hand pick, which causes a lot of ground loss. And this is the Packout data for Duke. The statistic difference was in % soft, that hand harvest Duke has the least % soft, which is 0.8%. And otherwise, there was no statistic difference between the harvest type. And in % Packout, numerically, you can find hand harvest has the highest % Packout, followed by modified overload harvester and the conventional overload harvester. Next is the Packout data for Draper. Again, there was no statistic difference. In the % Packout, hand harvest has the highest % Packout. And the difference between the % Packout among machine harvest is very slight numerically. this table is the Duke firmness data, and the statistic difference was on day 21 and day 28. On both 2 days, hand harvest Duke has the highest firmness compared to conventional overload harvester. And on day 1 and day 14, numerically, hand harvest has the highest firmness, then followed by the modified overload harvester and the conventional overload harvester. Next is the firmness table for Draper. The statistic difference was on day 21. And on that day, modified overload with soft material insertion has the highest firmness, and followed by modified harvester without insertion and hand harvest. And on day 14, day 21, and day 28, numerically, you can find modified overload with insertion has the most highest firmness. Next is the water loss data for Duke, and there was no statistic difference, and numerically, water loss in conventional overload harvester was the highest. And this is the water loss data for Draper, and the statistic difference was on day 28, that modified overload without insertion has the highest water loss. And numerically, you can find on day 14 to day 28, modified harvester with and without insertion has the most water loss. The reason for this may be due to the age effect. Since the three rows for modified overload harvester was on the edge of the field, which may lead into this abnormal water loss. Next is the result part for my second experiment. First, this is the percent blue before and after machine harvesting in Liberty. The percent blue before harvest range from 60 to 70%, and the percent blue after range from 9 to 15%. The only thing I want to point out that here is the percent blue before harvest in 3-day interval is the lowest, which is 60%. This can be one reason accounting for the lowest machine pick packout in 3-day interval in Liberty. So this is the packout data. The y-axis is the percent packout, and the x-axis is harvest interval. First harvest was on the left, then it is 3-day, 10-day, and 14 days interval. The blue bar is machine pick, and the red bar is hand pick. First, let's compare between the harvest type in each interval. The different lowercase letter indicates significant difference between the harvest type. So on first harvest and 10-day interval, there was no difference in percent packout between machine and hand pick. And on 3-day and 14 days interval, the percent packout in hand pick is higher than machine pick. Next, let's compare between the harvest interval in each harvest type. The different uppercase letter indicate statistic difference between the harvest interval. So the only statistic difference I observed was in 3 days interval machine pick, which is below 60%. And the percent color is 20.9%. The one reason for this could be the 3-day interval was too short, and there was a lot of green and red fruit get removed by the machine. Next is the firmness in machine harvest Liberty. The y-axis is firmness, and the x-axis is 5 evaluation day during the 28-day storage. And each harvest interval was grouped on the evaluation day. The dark blue bar is first harvest, light blue is 3-day interval, dark green is 10-day interval, and light green is 14-day interval. The average firmness of handpicked Liberty was marked in red on the top. And on each evaluation day, the average firmness of handpick was statistically higher than machine pick. Let's move to the first harvest. As you can see on all 5 evaluation day, the firmness of first harvest was always the lowest. The reason for the higher firmness in second harvest is more ripened and mature fruit get removed in the first harvest. Next, let's see the 3-day interval. On day 7 and day 14, the firmness of 3-day interval was statistically the highest. And numerically, on all those 28 days, the firmness on 3-day interval was the highest. Next, let's move on to the 10-day and 14-day interval. As you can see, there was no statistic difference between them. So therefore, it seems machine pick Liberty in 3-day interval has the highest firmness. But when you consider the percent Packout in 3-day interval, it may not be a better choice in 2019 in Liberty. And one thing I want to point out that is 2019 has a cold winter. So the conclusion here may not apply to a warmer season. In summary, in my first experiment, there was no in-row ground loss difference between modified over-the-row and conventional over-the-row. There was no Packout difference between harvest type in Duke and Draper. The firmness in Duke and Draper harvest by modified over-the-row was better than conventional over-the-row. In harvest interval experiment, 3 days harvest interval has the lowest machine harvest Packout. So 10 and 14-day harvest interval are better choices in terms of harvest efficiency and fruit quality in 2019 for Liberty. These are my first year results, and the experiment will be repeated in 2020. In the end, I want to thank to my committee member, Dr. DeVetta, Dr. Miles, and Dr. Sankara, and also my team member for field support. And especially I want to thank to Dr. Fumi Takeda from USDA, Brian, Scott, and Catherine from Oxford. And thank to Washington State Department of Agriculture and Washington Blueberry Commission for funding my research. And thank for Oxford for providing the harvest. And thank for Mayberry Packing and Ranji Farm for providing the field, and Munger's Farm for providing the packing. Thank you everyone for listening to my presentation. I'm happy to take your questions.